Hello everyone, welcome back to my YouTube channel. And if you are new to my channel, let me introduce myself. My name is Dr. Manpreet, and in the first video we have discussed about the valency, how to find valency and what is the relation between valency and periodic groups. Okay, so in this video we'll discuss about chemical formulas. If you missed that video, just go and watch that video. That is very important to write the chemical formulas. Okay, so let us start the chemical formulas. So I am showing here some important cation and anions, and let's discuss the cations first. So group 1 will show monovalent cations. Why monovalent? Because they have one valence electron. Okay, so one electron in valence shell, they can donate that one electron and can attain the stability. Okay, so that's why this one electron is lost. That's why cation is formed, and monovalent cations are formed for the group 1 elements like hydrogen, lithium, sodium, potassium, rubidium, cesium. All these are the monovalent group 1 cations. Okay, and for group 2 they have two valence electrons. They can donate these two electrons and they can form divalent cations. Divalent cations, these are the metals. Okay, so divalent cations will be beryllium, magnesium, calcium, strontium, and the other for D block elements, they can show variable valency and they can show different cations. Like iron, it can exist in +2 ferrous and +3 ferric. Similarly, copper +1, copper +2, and aluminium +3. This element belongs to third group, that's why its valency is 3, and some other are given here. Okay, anions, there are some simpler anions like chloride, bromide, fluoride. We have discussed why they show -1, because they have 7 valence electrons and they can add one electron to get stability, and adding one electron will give us anions. There are some polyatomic anions like we have carbonate CO3 2 negative, sulfate SO4 2 negative, and phosphate PO4 3 negative, nitrate NO3 negative, nitrite NO2 negative, nitrite. These are the polyatomic, not this one. This is monatomic because only one atom is there, and other are the polyatomic. Okay, so how to write chemical formula? These are the basic cations and anions which are we commonly use in chemistry. And how to write chemical formulas? There are three main steps to write the chemical formulas. First is to recognize cation and anion. Okay, first of all, what is given to you? You must recognize the cation and anion. Okay, then charges on cation and anion, and then third is try to balance charges. Okay, try to balance the charges of the cation and anion. Okay, just let's take the example here. First is given to you barium sulfate. Okay, the first one will be your cation. Always metal is written first. This is cation and this is anion. Okay, so for the first example, barium is your cation. Barium belongs to group 2, so that's why its symbol is Ba and valency will be 2, barium. And the anion is sulfate. Sulfate is SO4 2 negative. Okay, this is given to you. Next is you have to balance the charges. How to balance charge? There are two ways. First, general ways, you have cation +2, you have anion +2, and the overall charge on this barium sulfate will be 0. That means already charge is balanced, so the formula will be BaSO4. Or the second way is the charge on the cation will be the subscript of the anion, and charge on the anion will be the subscript of the cation. So that means Ba2 here and SO4 2 here. Okay, and second is you should write in the simplest form, because there are 2 and 2, we can cancel that, and the simplest form will be BaSO4. Okay, let's take the second example. We have aluminium. Aluminium belongs to third group and its symbol is Al, and the valence is 3, Al plus 3. And oxide is -2, oxygen has valency 2, that means it has charge -2. Okay, so we have already discussed about the valencies, why oxygen has valency 2, we have discussed in the first video. I am writing directly the formulas here. Aluminium plus 3 and oxide is -2. How to balance charge? Okay, let's do by the simplest way. How to balance charge? There are +3 and -2, we should balance the charge. If we take 2 aluminiums, charge will be +6, and we have to take 3 oxygen to get -6. Okay, so this is the way to balance a charge. So that's why Al2 and O3 will be our answer. Or if you like this way, let's write here Al plus 3, oxygen -2. Charge on the cation is subscript of the anion. Charge on the anion is subscript of the cation. That means Al2O3. Okay, this 3 goes to subscript of the O and 2 goes to subscript of the Al. So this is the oxide, aluminium oxide. Okay, so third one is calcium carbonate. Calcium is Ca plus 2, because calcium belongs to group 2 and valency will be 2. Calcium and second is carbonate. How to write carbonate? CO3 minus 2. Okay, so charge is already balanced, so you can write simply CaCO3 is a calcium carbonate. Or if you want to balance the charge by the second method, this goes here and this goes here, don't write charge, simply number 2 CO3 and 2, and to write in the simplest form, because this is the common factor, we can cancel out and the formula will be CaCO3. Okay, so let's do the next example. Magnesium hydroxide. Magnesium again belongs to second group, so valency will be 2, Mg plus 2. And hydroxide is OH negative. Okay, how to balance this charge? Mg plus 2, OH negative, OH negative, because there is +2 charge, we have to make -2. How to make -2? If we take 2 OH negatives. Okay, so basically magnesium hydroxide will be MgOH twice, 2 OH. Okay, or simply Mg plus 2, OH minus 1, this 2 goes here and 1 goes here, Mg1 OH twice, or simply MgOH twice. So this will be the formula, and this is the repeat one. And let's do this ammonium carbonate. Okay, so first one, ammonium is your cation and carbonate is your anion. Okay, so ammonium is NH4 positive and carbonate is CO3 2 negative. How to balance? We need 2 charge, 2 plus 2, that means we have to take 2 ammonium ions and 1 carbonate. Okay, and by the another way, this 2 goes to here and 1 goes here, NH4 twice CO3. Okay, here you have to write the formulas for sodium carbonate, sodium hydroxide, sodium sulfate. Okay, sodium belongs to first group, and the valency will be 1, that's why Na positive. Magnesium belongs to second group, its valency will be 2, that's why Mg plus 2. Chloride is Cl negative, hydroxide is OH negative, sulfate is SO4 2 negative. Okay, so here for sodium chloride, Na positive, Cl negative, charge is balanced, 1 plus 1 minus 1, charge is balanced, simply NaCl. Okay, so I am writing here NaCl. For the second one, this is the first. For the second one, sodium positive, hydroxide negative, charge is balanced, so simply write NaOH. Okay, so next is sulfate. Na positive, SO4 2 negative. We need to balance this charge. Here is minus 2, that means we have to take 2 sodium ions to balance this charge, that means Na2SO4. okay, Na2SO4, or simply you can say this 2 goes to subscript of cation and 1 goes to subscript of anion, Na2SO4. okay, so let's take another example for magnesium chloride. Okay, second one, magnesium is Mg plus 2 and chloride is Cl negative. How to write this? This goes here and 1 goes here, Mg1 Cl2. So basically MgCl2. Okay, second is magnesium hydroxide, OH negative. Similarly 2 goes here, 1 goes here, so Mg1 OH twice. You can write Mg OH twice. Okay, so sulfate, Mg plus 2 SO4 2 negative. So this is Mg2 SO4 twice, or simply MgSO4, because 2 is the common factor, you can cancel it, MgSO4. okay, so let's write the another one. Aluminium is Al plus 3, ammonium is NH4 positive. Okay, you have to remember, or you can just write sodium, symbol is Na, and sodium belongs to group 1, that's why valence is 1, Na positive. Magnesium is Mg and it belongs to second group, charge will be plus 2. Aluminium belongs to third or 13 group, Al its symbol, and the valence is 3. Ammonium is NH4 positive. You can simply write ammonia, and then ammonium is, there is positive charge by adding 1 hydrogen. Okay, so third example is aluminium carbonate. Aluminium is Al plus 3, carbonate is CO3 2 negative. Okay, so how to write this? 3 goes here and 2 goes here, Al2 CO3 thrice. Okay, so or you can just cross check this, Al plus 3, Al plus 3, and CO3 2 negative, CO3 2 negative, and CO3 2 negative, plus 6 minus 6, charge is balanced. Okay, so Al2 CO3 twice. Okay, sulfide is so carbonate is CO3 2 negative, sulfide is S2 negative, phosphate is PH4 3 negative. Okay, so aluminium sulfide, I am writing here Al plus 3 and S minus 2, same, 2 goes here, 3 goes here, Al2 S3, Al2 S3, and next will be Al plus 3 and phosphate is PO4 3 minus. So it will be simply Al PO4. Charge is balance plus 3 minus 3. Okay, so Al PO4. Okay, so next is ammonium carbonate. Ammonium is NH4 positive, and these are the important examples. Okay, you have to note down these examples: nitrate, nitride and nitrite. So ammonium carbonate, CO3 2 negative, so simply NH4 twice CO3. Okay, again I am writing here ammonium sulfide. Okay, and ammonium phosphate. Okay, just cross multiply the powers. Okay, so next is potassium. Potassium is K positive, calcium is Ca plus 2. Okay, nitrate is NO3 negative, nitride is N minus 3, nitrite is NO2 minus 1. Okay, this is your assignment question. You have to write the chemical formulas for potassium nitrate, potassium nitride, potassium nitrite, and similarly for calcium, and comment below. Thank you for watching.